Hi students, today we are going to derive an expression for escape speed or escape velocity. Now, if you want to go to the surface of some other planet, what we have to do is, we have to arrange for a craft, spacecraft or any body which will carry us to the other planet. So before entering the other planet, we have to escape from the gravitational attraction of the earth. Is it not? Suppose let us take an object like this. It is thrown upward. Okay, I'm going to push this up. Should I give some initial velocity in the upward direction or not? Yes. See here, very little velocity I am giving. It goes up, again it is coming back because of the gravitational attraction. Little more velocity, if I give, what happens? Little more height it will go and again it will turn. Little more, okay, greater velocity I have given. Again it is coming back only. But from the earth, if you project any object in the upward direction with a very high velocity of about 11,200 meters per second, that is 11.2 kilometer per second. With that, the speed if you project means it will be going up higher and higher and higher, and it will escape out of the gravitational influence of the earth and it will never return back. That means it will escape the gravitational pull of the earth. So it is called escape speed. The initial speed with which we project this upward is called escape speed. So minimum how much is required is 11,200 meter per second. Suppose if you give a velocity above this, like 11,800, 12,500 meter per second, definitely it will escape out of the gravitational influence. If it is less than 11,200 means again it will go to the greater height and from there it will freely fall. So we have to be very careful in giving the definition for escape speed. So what is escape speed now? It is the minimum speed. Understood? It is the minimum speed with which an object has to be projected from any planet or any satellite or any surface such that it will escape out of the gravitational influence around the surface. So for Earth, now we have drawn a picture. This is our Earth. Let ME be the mass of the Earth. RE be the radius of the Earth. Now on the surface of the Earth, let us consider this is a body which has to be projected. Okay, that is mass M. So it is initially placed on the surface of the Earth at rest. Now it will have a gravitational potential energy due to its position. From the center of the Earth, this body of mass M is placed at a distance of RE. So it will have a gravitational potential energy. Okay. So let us take the surface of the Earth is the initial point. Now at the initial point, okay, that is on the surface of the Earth. So what is the initial potential energy? Potential energy I means initial. So this is equal to minus of capital G into mass of this body M into mass of the Earth divided by the distance of the object from the center, that is RE. So this is the initial potential energy. Okay, now what next? With what velocity I am going to project this body upward? That is the initial velocity which has to be imparted to the body. And that is also equal to what? The escape velocity. Understand? So the initial velocity imparted at the surface of the Earth, VI, must be 11,200 meter per second from the surface of the Earth, I said. Is it not? That is nothing but the escape velocity. So we can also write this also is equal to what? The escape velocity. The initial velocity is its escape velocity. So with that velocity the body is starting from the initial point. So it must have initial kinetic energy also. So kinetic energy at the initial point, KE initial. So this is half into m into vi square, or ve square also you can write. So what is the total energy at the initial point? That is called the initial total energy. Understand? Initial total energy. Therefore, the initial total energy, that is denoted by the symbol TE, initial. So I am going to add these two. Understand? So this is minus Gm into Me divided by R plus half m into Vi square. This Vi square also is what? Ve square. So this is our equation 1. Have you understood first? So initial potential energy plus initial kinetic energy is the initial total energy. Now once it has started with that escape speed, that high velocity or high speed, at each and every stage as it goes higher and higher, its velocity will be decreasing. Is it not? Just like a stone which is thrown up, okay, its velocity will be continuously decreasing. And at the edge or the end of the gravitational field, the height is considered to be infinity. So here h is equal to infinity. At this height, the velocity will be 0 at one stage. Okay. So the velocity of this object will become 0 at infinity. That is considered to be the final point. Okay. So at the final point, I will write here at final point, that is at infinity. So the height h is equal to infinity and the velocity v is equal to what? 0. Now what is its potential energy and kinetic energy at that point? So here potential energy at the final point is equal to minus Gm into Me divided by this height. At this height, okay, body is at infinity, so this will be equal to 0. And kinetic energy at the final point is equal to half into m into v square is 0, because v is 0. So this also is equal to 0. Therefore, what is the final total energy? Therefore, the final total energy, which is denoted by the symbol total energy F for final. So we have to add the potential energy and the kinetic energy, so that this is equal to 0 plus 0, that is equal to 0. This is equation 2. Okay. Now, yes, gravitational field is called a conservative field. Conservative field. Okay. Just like conservative force and non-conservative force you have defined, this is a conservative field inside which the total energy of a body moving inside this field will remain constant always. So, Earth's field, okay, Earth's field is a conservative field. Earth's gravitational field is conservative. Therefore, the total energy at the initial point must be equal to the total energy at the final point. So I am going to substitute this equation 1 on the left side, and here we can take equation 2 on the right side. Now we substitute left side. What is on the left hand side to be written is minus g into mass of the body into mass of the earth divided by Re. Okay. Plus half m v escape square, because v initial is also equal to what? V escape, is it not? So instead of v I square, I am writing what? V e square. Okay. Now right hand side is 0, so this will be 0. Now I shift this negative term to the right side, it will become positive. So half into capital M V escape square is equal to G becomes positive now into mass of the body into mass of the earth divided by RE. Now which term can be cancelled on both sides? The mass of the body can be cancelled. So what is now VE square by 2 is there. I will write only VE square now, taking this 2 to the right side. Okay. So we write like this. Or VE square is equal to 2 into G ME by RE. Therefore, taking square root on both sides, V escape is equal to square root of 2G ME by RE. So this is the final expression for the escape speed, and this is the equation 3. Now in the NEET and IIT entrance exams and all, this formula only you will have to use. Find the escape velocity from any surface of the given radius and mass they will give. G is a constant you are supposed to remember. So this is the equation. Sometimes they will ask you to compare the escape speed, ratio of the escape velocity on two different surfaces. Mass of the earth and mass of the Jupiter, radius of the earth and radius of Jupiter will be given. What is the ratio of the escape speeds they will ask. So for that, this equation you will have to remember forever. However, now we discuss this in terms of the earth. Okay, so for earth, let us substitute some factors and get another expression also. Now you see here, students, we have already studied the relationship between small g and capital G. Is it not? What is G equal to? Small g equal to capital G into ME by RE square. This is the equation relating small g and capital G. Is it not? Now inside the square root, G term, ME term is there. Denominator RE is there. I want to make it as RE square. Is it not? So I multiply by RE and divide by RE inside the square root. So I am going to do some adjustment to substitute for small g. Okay. So the above equation is V escape is now equal to, okay, V escape is equal to square root of 2G ME, okay, divided by RE square. So I have multiplied here RE into RE. So in the numerator also I should multiply what? RE. Understand that? So now instead of this GME by RE square, what shall I substitute now? Acceleration due to gravity on the surface, not only on earth, for any surface also. Okay. Therefore, now V escape is equal to square root of 2G RE. So G is equal to what? 9.8 meters per second square on earth, and the radius of the earth is equal to 6,400 kilometer. If you substitute 2 into 9.8 into 6,400 into 10 power 3 meter, then some value, if you take a square root, some value you will get, is it not? That calculated value is V escape is 11.2 kilometers per second on earth. These equations are common for any surface, any planet. Now my dear students, you look at this equation number 3 and this fourth equation, let us say, okay, 4. Both are true for what? Escape speed. Can you see anywhere the mass of the surface mass of the body which is kept on the surface of the earth? So the mass or the mass of the body which is going to escape may have any mass. Understand? So the escape speed does not contain the term mass of the body which is going to escape. Okay? So it is independent of the mass. It is the same for a housefly as well as an elephant. You have to keep like this in your mind. Because to distract from you in the competitive exams, find the ratio of the escape speed of two objects, where the second is having double the mass of the first, or the first is double the mass of the second, like that they will ask. Okay, it does not depend on the mass of the object. It is the same for any object. It depends only on the dimensions of the planet or any surface. Okay, so now we have calculated the value for the escape speed of the surface of the earth. So the starting speed itself should be how much? Minimum how much? 11.2 kilometer per second. And on moon escape velocity is equal to 2.5 kilometers per second on the surface of the moon. Usually there will be a question, why moon is not having an atmosphere? Before several thousands of years, you can say the moon was having a beautiful atmosphere with hydrogen, helium, nitrogen, carbon, oxygen and all. But after receiving some strong thermal radiations from the sun, the temperature, the average temperature of the gas molecules has increased, and the average velocity of the gas molecules have exceeded 2.5 kilometers per second. So naturally what will happen, if the velocity of the vibrating molecules of gases will be more than 2.5, means they will escape, they will go away from the gravitational field. This is the reason why moon is not having an atmosphere now. Like that, if we calculate the escape speed on the surface of Jupiter, it is 60 kilometers per second on Jupiter. Okay. So like this, for any surface, we can calculate the escape speed. So my dear students, you must remember that the escape speed does not depend on the mass of the object which is going to escape. And also the angle of projection. The angle of projection may be any value, okay, for any angle, the same value of escape speed only it will have, understand? So what is escape speed means, you have to define carefully. It is defined as the minimum speed with which an object has to escape from the gravitational influence of any surface. I hope you must have understood well. Fine.